is not equal.
Two-sided test means you have not equals in the alternative. Greater than or less than means you have a one-sided test. Does everything sound reasonable? Yes. Okay, so then let's try a problem. And let's see how far we can get. Okay. Well, and then once you have your p-value, then you can choose to reject or not reject the null, right? By comparing it to alpha. Alright, so we'll say, someone says the mean weight of adult women in the US is 145 pounds. I have no idea. Okay. Someone says that. We take, it's something around that, but I don't know. Okay, I don't know what it is. We take a random sample of 15 women. Okay. The mean weight is George, let me borrow your pen. Okay. Okay, the mean weight is 156 pounds. Is the standard deviation of our sample? Standard is 22 pounds. Is this evidence that the mean weight is not 145 pounds? Okay. Use alpha equal to 0.05. So, figure out your hypotheses. Figure out your test statistic. And figure out your p-value. Okay. Try that. Do your best.
And then
So
the alpha,
you alpha
or
that
the
has nothing to do with
no, not the alpha.
Just trying to.
You did that.
Did you get this
I
one?
did, okay, I did that. I didn't do not equal. I put greater than 156, right?
Yeah.
Not
It says no. It says the mean weight is not 145 pounds.
No, it says the mean weight of adult women in the US is 145 pounds, the mean weight is 156.
I know, but at the end it says is that the evidence that the mean is not 145.
That's what I thought.
That's the answer.
She said the same thing.
It's why.
Oh, that is your answer, is what you're saying.
Yes.
Oh, but I'm way back there.
Oh, I see. I'm way off that.
So wait, what did you do?
1.9366.
How did you get it? I haven't got it yet.
Well, I don't know what to do after that.
Yeah, me too. So wait, is this right? So I did this, and this, and this, right? And this, and this.
Right.
And then you do this?
I find 3.8.
I haven't got there yet.
You haven't got there yet, because I don't have this number, the T. Right?
Yes. No,
So
no,
how do
first
I
you
find
have
this
to,
again?
you have to do
I'm
this.
saying.
You have to get this.
Wow.
Because the
Okay.
Alright, let's okay, so I saw some good work.
Okay, we'll find
I
out.
saw some good work.
So, 5.
Okay, so I'll put the answers up backwards. Alright? And then we'll work through it together forwards, okay? So your p-value is gonna be more than 5%, but less than 10%. Your test statistic is going to be 1.936, I believe. Let me just check on that.
Yeah.
Yeah, 1.936. Okay. Or, I don't know, 1.9365 if you want to keep it.
Is that where you double?
No, you double our p-value. We'll
Wait,
get to it,
just
we'll get
wait,
to it,
just
okay?
wait.
Alright, so the null hypothesis, let's start off. We read the problem. So someone says that the mean weight of adult women in the US is 145 pounds. Blah, 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 blah. Alright, we take a random sample of 15 women. The mean weight is 156 pounds. That's our sample mean. And the standard deviation of our sample is 22 pounds. Is this evidence that the mean weight is not 145 pounds? Okay, so this is the question that we're after. Is this evidence that the mean weight is not 145 pounds? So that tells us that our null hypothesis, we want to know, is mu equal to 145?
Right.
And our alternative, do I use mu doesn't equal, greater than, or less than? Doesn't equal 145. Because it just said, is this evidence that the mean weight is not 145? It didn't say, is this evidence that the mean weight is more than 145? Or is this evidence that the mean weight is less than 145? It wasn't written that way, so we have mu.
So the 156 was just a red herring.
No,
No?
the 156 is vital to our problem.
Alright, keep
okay?
going, keep going.
But the question in our hypothesis, the value we put in there is 145. Okay, so that's our hypothesis. As we do our problem, we need to identify x bar, s, and n. What is x bar? That's our sample mean, that's 156.
Ah, okay.
What's our s?
Oh.
22. And what's our n?
15.
15. Okay, so with that, I can get my test statistic.
Got it.
My test statistic is x bar minus mu divided by the standard error. My standard error is S22 over the square root of n. I get, what is that? 5.6804. Doesn't matter, okay. 5.68. If you want to keep more decimals, that's fine. 5.68. So my test statistic is going to be 145 minus 156 I'm sorry, I should put a negative there, divided by 5.6804.
It's opposite.
Did I mess something up? Oh, I'm sorry, my x bar is 156. Thank you, tripping myself out here. Thank you. Okay, 156 minus 145. The mu is the one that comes from your null hypothesis. So 156 minus 145, I get 1.9365. Alright. Is that good? Alright. So now, I look this up in my t-table. I have how many degrees of freedom? Degrees of freedom is 14. I go to 14 degrees of freedom. I look at my row. And I'm looking the relevant values. I've got 1.771 and 2.160. 2.160 is t.025 and 1.771 is t.050. So 1.9365 is in between these two values.
That's 13.
Is that 13? Oh yeah, okay. That's good. 1.761 and 2.145. So yeah, sometimes I make mistakes like that, but our thing still works out, okay? And so I know that my my test statistic is in between these two numbers, so my tail is in between these two numbers. Okay, is that okay? So my tail is going to be more than 0.025, but less than 0.05. Yes. Yeah. So the last step, okay, so with our test statistic, we figure out a p-value. Our p-value is 2 times the tail for two-sided tests, okay? And according to our hypothesis, I have a not equal sign, which means I have a two-sided test. Okay, so I have a two-sided test, so I've got to, this is where I do my doubling. My doubling of the tail is right here. So my p-value is 0.025 times 2, so greater than 0.05, and then I multiply 0.05 times 2, and I get 0.10. So I double this. Double this to get my p-value. Okay? So my p-value, I don't have an exact number, but I do know for sure that it's more than 0.05, but less than 0.10. Is that okay? No? You don't have a question? Alright. Any questions? So I did s over the square root of n. So I did 22 divided by the square root of 15. And I got 5.68. So that you should just get that when you punch that in your calculator. Alright. So the very, very last bit. This is my p-value. My p-value is between 5 and 10%. I said alpha is 0.05. So, do I reject or not reject my null hypothesis?
Don't reject.
Okay? Yeah. So, how is my p-value bigger or smaller than alpha?
Bigger.
It's bigger. Okay? Alright, my alpha is 0.05, and even though I don't have an exact value, I do know my p-value is bigger than 0.05, but less than 0.10, okay? So I know my p-value is bigger than 0.05, so our p-value is greater than alpha, so we do not reject the null hypothesis. So what does that mean? we would say we have evidence or we don't have evidence of what? Yeah, we don't have evidence that the mean weight of women is what? Is not 145.
Wow.
Okay? Because that's what our null hypothesis states. So we did not reject the null hypothesis. So we are saying this is a possibility. Okay? We don't have enough evidence to rule out this possibility. Does it mean that the mean weight of women is 145? No, it doesn't mean that the mean weight of women is 145. It just says, you looked at 12 women, it's not enough for us to say that it's not 145. Even though the mean weight of these 12 women was 156 pounds, which is 11 pounds more than 145, even that is not enough for us to say that the mean weight is not 145. Alright, so let that sink in. Is that okay? Alright, so we'll take a 10-minute break, and we will come back and deal with two samples.